All right, my name is Tomasz Janczuk. I'm the VP of a company called Auth0. Auth0 itself is providing identity management as a service, but within Auth0 I'm actually leading a small group of people who are trying to build a second product that deals with serverless webhooks. Supposedly there is a Chinese curse that Albert Camus refers here to, which basically goes along the lines of let you live in interesting times, where interesting times are meant to be something negative. Looking at it from the perspective of our profession, I actually never understood that sentiment. I kind of found it very exciting to be living and working in a space that evolves so rapidly. There are always so many interesting trends that kind of intersect and new things coming up. And one of the things that, two of the trends that I like to focus today on are serverless and SaaS, and how these two can complement each other. Serverless is a relatively new phenomenon. The term was first coined about 3.5 years ago. SaaS is a much longer term trend. So let's kind of start looking at serverless and revisit where it came from and where it is going. A long time ago, when I was young, I had a PC. And it was a lot of joy to kind of be able to put it together, memory sticks, hard drives, CPU, you kind of owned all of this very low level work, a lot of hardware. It was a very enjoyable thing to do for an engineer. However, from a perspective of a company who wants to run a software on top of it, it was actually a big nuisance. All the hardware to maintain, all the operating systems to run and so on, it was just a pain. So it is a natural evolution of the way people do computing that at some point the concept of infrastructure as a service was born. Around 2006, Amazon first released EC2. So basically the value proposition behind infrastructure as a service was we will take over maintenance of all that hardware for you. So instead of thinking of hard drives, memory sticks, replacing broken hardware, connecting the wires to set up networking, we will give you an abstraction called a virtual machine. And you will own what's installed on that virtual machine. You will decide how many of them you want to run, and this is how you will operate the software. Infrastructure as a service still comes with a lot of oftentimes unwanted taxation. You own pretty much everything that sits within that VM. So installing patches to the operating system, installing patches to the applications you're running, deciding how many of the VMs you need to operate your system was still on you. So for some businesses, it made sense to actually invest in something called platform as a service. The value prop of platform as a service was you no longer have to think about VMs, operating systems, scalability. You will take it on. All you have to think about is actually your application. You decide to deploy a certain application, and the provider of platform as a service will provide facilities to very easily scale it, install patches to the underlying operating system, and so on and so forth. An example of a PaaS is Google App Platform, or places like Heroku, where you just deploy an application without having to worry about the underlying operating system. So many of the apps deployed today use this paradigm, but there is one more thing that can be done to simplify how people look at the structure of the deployed application today, and this is function as a service, FaaS. This is really what equivalent to what people are calling serverless. This is something that started about 3.5 years ago. The term showed up on the scene, and to describe a way of thinking about structuring an application where the fundamental concept a developer is thinking about is just a single function. So instead of big monolithic app, you think of a single function, you don't worry about the scale, you don't worry about the underlying operating system. You're quite far away from the early days when you had hard drives, memory sticks, and so on and so forth. What defines FaaS or serverless is thinking about apps as thinking of functions as fundamental units of computation. So you deploy individual functions. This paradigm yields itself therefore very well to developing microservice-based architectures. Another value prop that is drummed up by platforms that offer FaaS is the billing structure, which is very, very granular. You basically pay only for the compute that you use. You spin up a function, you can scale the function depending on the load, but eventually you only pay for, almost like a mobile phone billing for a sub-second granularity. So high level, new paradigm, started about 3.5 years ago. This is a little timeline of this and the overview of the vendors that are available today. It started around October 2014, that was actually even before the term serverless showed up on the scene. Hook.io is a startup that offers an easy way to create webhooks. So you come in, you write the code, you get a URL that you can later take and plug into some system that requires webhooks. The term serverless really was coined when Amazon shipped Lambda in November 2014. And Lambda, to this day, remains the big elephant in the room. When people say serverless, they typically mean Lambda, even though there are many other vendors that have showed up on the scene after Lambda. Webtasks.io shipped in 2015. This is actually something that we have done within Auth0. Webtask we started working on Webtask as a technology to execute serverless functions even before Amazon shipped Lambda. When we started, we weren't even aware of that serverless trend that would soon kick off. However, in 2015, when we shipped, the term was already well established, so we attached ourselves to this simply because we knew that technologically it's a very similar solution. A year later, 2016, Google shipped Google Functions. IBM shipped Bluemix that includes OpenWhisk. This is based on OpenWhisk and also includes support for running functions. And last but not least, Microsoft Azure came out with Azure Functions in November 2016. So the history is very brief, about 3.5 years, quite rapid evolution of that serverless trend. There is a lot of buzz around serverless right now. Many people are trying to build microservice-based applications using one of these providers. So let's have a look at what that experience looks like for serverless. I'm going to go to Webtasks.io. So Webtasks.io is a site that we are hosting pro publico bono. It's a free service. You can come in and basically very quickly create an endpoint. So you go in here, click try it now. You get into a code editor. You can create a new function. You can call it matters. And many of the vendors offer some kind of an authoring experience for functions. The common denominator between the vendors and the way these functions are authored is that typically they pick up a certain programming environment. In this case, this is Node.js and the ecosystem of NPM modules around it, but functions can also be authored in Python, Go, or other languages if you are using Lambda, for example. The common denominator here is that the unit that you are thinking about is just one function, one procedure in a given language. So what you are seeing here is a single Node.js module that exports just a single function. And this is the unit of business logic that you are implementing. So in this case, you have a very simple function that accepts context on input. Context will represent the request that is used to trigger execution of this function. So you can eventually extract data from that request. If it is, for example, HTTP post, you'll have access to the body of that post and headers and so on. And you can produce some kind of a response. The function in this shape can accept and respond with JSON data. We can, for example, say here, hello matters. We save this function, grab the URL, and when we call it, it'll basically respond with that JSON that we generated. So one of the premises of serverless is a very, very quick development cycle. And Webtasks.io is just one example of how you can very quickly implement some business logic, expose it over HTTP, and make it available to any HTTP client, including some systems that require webhooks. In addition to providing JSON input and output, you can also drop down to the full HTTP programming model, at which point you can do something like write head 200 content type text HTML or end. So functions are not restricted just to JSON. functions is a very abstract term that really means an endpoint, at least in the context of Webtask IO. If you're using Lambda, if you want to expose full HTTP programming model, you have to use it in conjunction with API gateway that allows exposing Lambda functions over HTTP. So if we take this endpoint now, and it's actually the same endpoint, and refresh it, we'll get back that HTML that I just authored. So Webtask allows you to very quickly create an endpoint, returning any data, JSON, HTML, images, or whatever you desire, and the unit of computation is a single function. So this, in essence, was the serverless trend. Very brief history, 3.5 years, very rapid development, many providers for serverless functions. Again, the common denominator is that the unit of business logic is just one function, oftentimes exposed over a single endpoint. So let's switch gears and talk a little bit about SaaS. SaaS actually has a much longer history than many people expect. SaaS actually predates cloud big time. SaaS started in 1960s. Turns out 1960s was quite an interesting decade as well, almost as interesting as the times we are living in right now. Many firsts. First person in space, first people on the moon, first heart transplant, Beatles, and so on. But the one event that really kicked off SaaS as a way of delivering software was IBM creating System 360. System 360 was the first mainframe system that gained widespread adoption. System 360 was later used for the next 20 years almost. The idea behind System 360 was that applications on a mainframe was centrally installed and maintained, and many employees, typically of the same organization, would have access to that one application from terminals. This really represents the essence of software as a service. It is centrally installed application with many access points, and mainframe was the very first example of delivering it. The difference between SaaS in this context and the SaaS as we understand it today is basically the scale at which that application is available. Back in the 60s, 70s, and 80s, when mainframes were used, the scale was typically one organization, and the application was delivered over local area network. The way we understand SaaS now is quite different, but we'll get to that. There is one other event that actually laid the foundation for further evolution of SaaS as a software delivery paradigm, and this is the first Arpanet connection. So this basically created the foundation for what is known today as internet. Going into the 90s, the SaaS paradigm was implemented using what was back then called application service provider. Application service providers, so this is 1990s, is already, internet is already available. So companies are connected to the internet, they can connect to some data centers and so on. So a business model that came up was there were companies who were offering hosting of dedicated instances of specific applications. So for example, a company that needs a CRM system could contract out maintenance of that dedicated installation of the CRM system with an application service provider. And the clients who are typically employees of that company would then remotely connect over internet to this application. It still wasn't the SaaS as we know it today, simply because each client of an application service provider would get a dedicated instance of that application, and typically there would be some rich clients involved in connecting to this backend. So people, the employees of the company who was contracting out maintenance of that system would have to install their own software in order to connect to this application. So this has changed in 1999 with the first, what I call modern SaaS company, Salesforce.com. Salesforce.com realized that with a widespread access to the internet, standardization of protocols, HTTP, SOAP, REST, and the normalization of clients, web browsers were already very popular. A different kind of SaaS was now possible, one which is not a single tenant, but is multi-tenant. Salesforce.com maintained that system on behalf of many companies. Individual users could actually connect to this system using standard internet protocols, HTTP using browsers. So this is what the SaaS as we understand it today pretty much. You go out to Twilio, create an account, you can call APIs. Many other SaaS companies operate this way since Salesforce.com started. There were other attempts at creating SaaS like this prior to Salesforce, but Salesforce was really the first one that proved this model and was successful with it. So what is SaaS today? According to Gartner, this is a huge market. Close to half of all the software delivered in 2021 will be based on the SaaS model. So this is definitely something that is kind of on the uptake in terms of the trends. One interesting thing about SaaS is the model on which SaaS is based is the possibility of integration. 1999, Salesforce.com is in the cloud. Imagine a second SaaS company. In this case, I'm using Slack as an example, but a second SaaS company shows up on the scene and they are also running their system in the cloud. One thing that is now possible that wasn't possible back in the era of mainframes is it is very easy to actually integrate these systems. They are running in the cloud, they have interconnectivity using standard protocols, HTTP, REST, and of course TCP/IP, which underlies all of internet. So one possibility that materialized in this environment is that now a single SaaS platform can actually do much more by enabling integrations with other SaaS platforms. So imagine Salesforce.com. This is a big CRM system. Let's say you are creating a new lead or an opportunity in Salesforce.com, and when that happens, you want to send a message to Slack. Like this. So this is now possible by basically integrating these two systems together. But the interesting phenomenon behind these integrations is that as more and more of companies are providing software as SaaS, the number of possible integrations between these systems is actually growing polynomially. So if you look at it from the perspective of any single SaaS platform, for example, Salesforce, it is completely impractical and impossible actually to keep up with the growth of the ecosystem, cloud ecosystem, and provide out of the box all the possible integrations. The engineering team simply cannot keep up with something like this. People started looking at this problem, and in 2007, Jeff Lindsay came up with that concept of a webhook. The webhook is a very simple concept. He identified events that originate in SaaS software that wants to integrate with another piece of software elsewhere. He called those events webhooks. The basic premise behind this model is that someone external to a SaaS platform can come in and provide a URL that the core of the system will invoke when a certain event happens. So basically, Salesforce.com, in order to integrate with Slack, Salesforce.com would not have to be aware of the existence of Slack. They simply define certain events that make sense in the context of Salesforce.com, like on new lead created. And when that event happens, they issue an HTTP post request with a specific payload that can be intercepted by some intermediary piece of code, the webhook implementation, which in turn can turn around and call some APIs that Slack.com exposes. So this is how that looks like. On the Salesforce.com side, people can come in and plug in a webhook, webhook is a definition of an event with an associated HTTP URL to invoke. Slack in turn exposes some APIs that can be passively called from the outside. So someone who's interested in integrating Salesforce with Slack would come in, set up a new web service that provides an endpoint which Salesforce can call when the event happens on the Salesforce side. The implementation of that web service would then turn around and invoke the API in Slack.com. This is how, when a new lead is created in Salesforce, you can see a message showing up in Slack. So let's have a look at how that experience looks like. So this is a hypothetical CRM system. This is a sample app, call it Zero CRM. So you'll have a concept of leads in a system like this, accounts, opportunities, and so on. You can come in here and create a new lead with a value of 5,000, provide an email address. You create the lead, which typically creates some representation of the data on the backend of Zero CRM system. And this is a sample representation of the data, a piece of JSON, which pretty much contains what I just entered. However, internally, what the system also did, it generated an event, which is represented as a webhook in that system. When a new lead is created, my Zero CRM system can invoke an external service, which in turn can perform any number of tasks. It can, for example, send that message to Slack, but it can also call out to a service like Clearbit to take the email address of that lead and basically enhance the profile of that lead. Get the company that person is working for, all the history around them, such that the salespeople using Zero CRM can then later better process that lead. So historically, using the concept of webhooks in a application like Zero CRM, you would have some kind of a settings page where all the custom actions or the events that the system may generate can be defined. For example, in here you'll see on new lead, and you can come in and plug in your own myserver.com on new lead. The interesting thing about this model is that it puts the person extending Zero CRM on point to actually set up and maintain the service. So typically you'd have to go and find a place to host it, Heroku, Azure Websites. Bottom line is it would live outside of Zero CRM. There is a protocol boundary between Zero CRM and the implementation of that webhook, which on one hand is super flexible because it decouples the implementation details of Zero CRM from the webhook. They can be implemented in completely different technologies. On the other hand, it creates a lot of friction from someone extending the system because now I'm on point to actually go and run a service effectively. Given that you have to run that service, what can you do? And this is where all the computing paradigms that we just discussed a moment ago come in. You can either use infrastructure as a service, you can use platform as a service, or you can use serverless function as a service. And it turns out that if you look at the concept of a webhook, which is a single endpoint, FaaS is actually an ideal paradigm to implement webhooks, simply because you have that parity between one event in the originating system, which translates into one webhook in the system, one HTTP endpoint which implements that webhook, and that oftentimes maps very well onto one function in whatever language you choose. So one naive approach to implementing webhooks would be use something like Webtasks.io or Hook.io, which is basically a separate platform that allows you to go write the business logic. You'll get back one URL, one endpoint. You take this URL and you plug it back into the Zero CRM or whichever SaaS exposes the webhook concept. However, there is a much better way of using serverless to embrace the concept of webhooks. It's almost like an evolution of the webhook concept, which I call serverless webhooks. So if you look at that Zero CRM application and you navigate to that settings page again, same page, same events as before. So same concepts exposed to the end user, but now instead of actually asking the person extending Zero CRM to plug in their own URL, we can provide them with a built-in editor that simply allows them to go and implement the business logic. So from the perspective of Zero CRM or whichever other SaaS is being extended, this actually is a big value proposition because it removes a lot of friction from the end users of that SaaS from extending the system. And typically, in a typical dynamic of any SaaS that offers code-based extensibility using webhooks, if you have users who are actually using webhooks, these are the most sticky kind of users because they have already invested in the platform a lot and they are much less likely to leave for the competition. Anything a SaaS can do to remove the friction from extending the platform is actually hugely beneficial to the SaaS. So this is a simple function that is invoked when a new lead in the system is created. And what you can see here is I'm actually modifying the profile of that lead that is created, and I determine whether that lead is a VIP based on the value the salesperson entering the data provided. So in here I set a threshold of 1,000 currency units. We can change it to 20,000. So when I go to my Zero CRM right now and I create my lead value of 5,000, you will see that VIP is false. But when I enter 50,000, you'll see that it was flipped to true. So the function was kind of immediately effective. So from the perspective of the end user, it is actually, we've cut out a lot of busy work related to extending the SaaS platform by providing a built-in IDE when they can just come in, implement the business logic and move on without worrying about hosting that code somewhere and effectively running a service. So SSL certificates, monitoring, and so on and so forth. So this is a very, very new trend. Pretty much any SaaS platform that is available today embraces the concept of a webhook. There is a place to come in and plug in that HTTP URL. However, there are already some companies out there that are embracing that model of serverless webhooks. Twilio, for example. Twilio is a SaaS company that allows you to manage SMS messages, voice messages, voicemail, and so on in a programmatic way. They offer a very rich set of, they have been always offering a very rich set of webhooks. And recently, a few months ago, I think, they shipped something that they call Twilio Functions. So this is a built-in experience built on top of AWS Lambda that enables people to come in and actually use that text editor here to author the code that will execute when a certain event in the system happens. So people no longer have to come in and provide the URL of the webhook. They can still do it. That model is still supported, but to remove the friction of extending the system, they provided that model of functions. Another example is Netlify. Netlify is a SaaS that enables you to very easily host websites that are associated with a repository in, for example, example, GitHub. They don't provide a built-in mechanism to author code because they are already integrated with GitHub, but they provide a model where you simply author the code as a file in your Git repository, and they will turn it into something that is executed at runtime. Conceptually, this is actually a very similar model to what Twilio has done. These functions that Netlify exposes can either be application-specific backend functions for the app that is being hosted, but they also have certain lifetime events specific to hosting of the application itself. For example, when deployment happened, they can execute some function that you specified in GitHub. Auth0, the company I'm working for and primary product of that company, identity management, is also extensible using the same concept of serverless webhooks. So we actually started this back in 2014, even before serverless was a thing. If you go to the management dashboard of Auth0, you'll see something called hooks. So hooks are places in the authentication pipeline that are invoked when a certain event happens in the process of authenticating a user. So let's say someone is using Auth0 to authenticate their users. It means that they will be calling into our endpoints to initiate the authorization transaction. In the process of that authorization transaction, let's say they chose to expose Facebook, Google, and Twitter as identity providers. In the course of that transaction, at some point the user is already authenticated, and we are in the process of getting a profile representing that user from, let's say, Google. This is one of the many points in the lifetime of that transaction that can be customized with code. And some of the things that people can do in that code is, for example, look at where is that user logging in from. And let's say in 99 cases that user had been logging in from the United States, and now we are seeing a login from China. So just for that single transaction, that custom code can decide to enable multi-factor authentication for this user, to basically require them to use their phone to confirm their identity. When you define a hook like this to inject custom logic into the authentication transaction, you'll see the same text editor that you saw a moment ago in that Zero CRM, where you basically go here, you have access to the whole ecosystem of NPM modules and Node.js, and you can modify that logic. And lastly, this is the product that I am actually working on, called Extend. So Extend is not a product that is extended with serverless webhooks. It is actually a platform that enables you to implement this functionality within any SaaS. So if a SaaS platform wants to embrace the concept of serverless webhooks, this can be had as managed service in the form of Auth0 Extend. Coming back to that central question, will serverless computing change the way you integrate SaaS platforms? Again, we live in interesting times. It is hard to tell, but I think there are too many things coming together in these two trends, serverless, webhooks, and SaaS, for this not to turn into reality. And many of the companies that are already embracing this paradigm, Twilio, Netlify, Auth0, are kind of a testament to the fact that there is something in it. So this is all I had for today. Any questions?
I have one question about Node.js. Do you use Node.js to make a function service? How do you use Node.js? It's possible, for example, I put in the cloud Node.js and I want to make my own functions as a service. It's possible? So
to make sure I understand, you're asking how you can use Node.js to create your own function as a service?
Yes.
So in case of Webtasks.io is actually a sample deployment of the Extend product that we offer. The IDE that is provided, let's actually switch back to it. The IDE that is provided here is just a code editor that enables you to capture the code, but you can also add any NPM modules from the public repository. So for example, you want to use MySQL. You can add MySQL, and now you can basically import it here. And use it in your application. So, with Node.js as the core programming environment, in conjunction with the ecosystem of all public NPM modules, which are in excess of 500,000, I think, right now, you can accomplish pretty much anything from within this code. If you want to call into Twilio, if you want to call into Slack, integrate with Atlassian, it's all possible between JavaScript, which Node.js is based on, and the ecosystem of NPM modules. What happens under the hood when you author this code, the source code and the metadata associated associated with it, which is pretty much the list of modules that you depend on, but also some configuration details and metadata are captured on the extend platform. And later on, when you come back to invoke this function using the URL, the second layer of the extend system is responsible for actually executing this code in a secure multi-tenant sandbox. So we will make sure that all the code is deployed, all the dependencies are present, and only then that code will execute. Effectively, what you have done, you have created a mini HTTP server, which only has one endpoint, right? So this is the mode of execution that extend and Webtask IO offer. Does that answer your question? So the question is the extend similar to Zapier? It serves a similar purpose. It does it in a completely different way. Zapier, or if this then that, there is a class of SaaS companies out there that basically offer pre-made integrations, right? So you choose, for example, I want to integrate Salesforce with Slack. And from there, you only have a few declarative text boxes to fill out. Like, these are my credentials for Salesforce, these are my credentials for Slack, this is the event I want to capture, this is possibly how I want to form the message that will be sent to Slack. You don't write any code typically in services like Zapier or if this then that. So it addresses the same need of system integration. It just appeals to a different audience. Declarative services are meant for less technical audience than something like Extend, which throws people into code immediately. Extend, or any other example of serverless webhook, really targets developers, right? People who would otherwise implement that webhook themselves. It just removes a lot of DevOps friction from the act of extending a system. Does that answer the question? So the question is, how does versioning work in this environment? Are you asking about versioning of the APIs that are called from within this custom code? Like, for example, Slack APIs, or versioning of the... Yes, so this is about the versioning of the systems that are being called. We are basically saying identical to really someone implementing their own webhook. They are on point to control what services they call and react to any changes in the APIs that these services offer. Put yourselves in the shoes of someone implementing a regular webhook, as it is known, a GitHub webhook or Salesforce webhook or whatnot. You write some code to, let's say, call out to Mongo database to add some data to it. Since this is your code, you are on point to version it, right? You have full access to version this code. You can come back at any time and modify it. And the same story applies to services like Extend or any other places where the concept of serverless webhooks is used. If you go to Twilio Functions, you write a piece of code and you are on point to make sure that it stays current. So right now we don't, so the question is about monitoring of a function. How do you know the function really stops working? We don't offer anything out of the box that would be any different from taking this piece of code and hosting it on, let's say, Heroku. You will have the very same monitoring problem when you host it on Heroku. So short of that code being completely broken and just like throwing an exception, which is relatively easy to detect, because let's say I do this. Let's say I make a syntax error like this. Right? When I invoke this endpoint, I will get an error immediately. So this is very self-discoverable, of course. But more nuanced situations where, for example, you are calling out to an external API that changed its behavior, it is still succeeding, but just not doing what you expect it to do. These are much more nuanced, and there is no monitoring that a system like Extend or Webtasks would provide for situations like these.
About security, isolation between customer, do you have to modify the Node.js environment, or do you do beforehand on the system?
This is a fascinating question. Security of a multi-tenant sandbox. Effectively, what is happening in serverless, and every platform vendor had to solve this problem in one way or the other. What you are seeing here is effectively Heroku in the box, right? You are getting one platform that is capable of running code on behalf of many different users who are not necessarily behaving nice to each other. How do you sandbox this code? And every vendor approaches this differently. In our case, when we started implementing this technology about 4 years ago, the Webtask technology, we started building it on top of Docker containers. Docker containers are a very useful kind of DevOps concept. However, they were not designed from the ground up to be the security isolation mechanism. So we had to build actually many layers on top of and around Docker to provide a level of isolation, basically ensuring fair use of CPU, ensuring fair use of disk, network, and so on, and isolating the different pieces of code that are effectively executing on the same VM. So we are using things like, in addition to all the security features that come with Linux containers, we are also using custom firewalls, we are customizing PEM limits, and are using many of the more traditional security mechanisms that come with Linux to complement and kind of secure the sandbox in which this code executes. You know, Auth0 is a security company. We do take security very seriously, so we put a lot of effort actually in making sure that this multi-tenant sandbox cannot be broken out of, including, you know, some external pen testing and things like that. So we are pretty confident this is, I'm sure, not impossible, but very hard to break.
Does it support also the enterprise version?
I'm sorry?
Or Auth0, there is an enterprise version also? So this one which can be deployed inside the company.
So are you asking about the identity management system? Or the? Yes, there is. So Auth0 has a self-service set of plans where you can come in and basically click through and get the identity solution for your application. Many people are starting from that, but we also offer a very, very robust enterprise offering, which is very dependent on the individual situation, including deployments on premise, so unattached to the cloud. Lately, we are even expanding into going to so-called dark sites, which are completely disconnected from the internet, and we also support deployments in those environments.
Also for security, is there a mean to secure communication with between APIs, for example, between Slack and
yes, so
the CRM?
That's a very good question. So typically when you write your webhook, it doesn't have to be a serverless webhook, any webhook anywhere, and you want to call some downstream APIs. For example, you want to connect to Mongo database or call into Twilio APIs to send an SMS or Slack to post a message. You must have a place to securely store credentials to authenticate against those APIs. Of course, it is not a good idea to bake those credentials into the source code itself. So what many of the platform vendors provide their own mechanism to specify configuration that is somehow protected at rest. And we also have a mechanism like that called secrets. So with secrets, you can, for example, define Twilio key here, provide its value, and save it. So that data will be saved along the webtask, that function that you define here, but it will be encrypted at rest. And it will only be decrypted when you actually invoke this code at runtime. So it will be made available at context, secrets, and you've got the key here. So it will be provided at execution time to the code. So very simple mechanism that solves the problem of secure storing of credentials. Yes, so this is all hosted on HTTPS, of course. So in this system, the question was how do we handle memory usage and request timeouts. So in the system, many of the configuration parameters that put limits on the resources that the function can use or the time it can take to run are configured at what we call a deployment level. A unit of deployment is actually one extend instance. So this is a dedicated cloud service that can support many different functions running on behalf of different users. So it is a multi-tenant system. However, the parameters that control the limits on individual functions are configured at the deployment level. So you have control over things like maximum amount of memory that can be used, a CPU share, what we call inactivity timeout. So the way we limit the maximum, we don't have a specific limit that says your function cannot execute longer than X seconds, but we have a limit around the lifetime of the container in which that function runs. So specifically one practical limit that will imply how long your function can run is what we call an inactivity timeout, which by default on Webtask IO is 30 seconds. So inactivity timeout basically designates a container for recycling if it has not received a new request to execute a function within a certain period of time. So given that this is set to 30 seconds, you are kind of guaranteed that you will get at least 30 seconds to run your function. You can get more than that, but you're running a risk if you do this.
Is there a mean to collect logging? That's mean when I write console.log.
Yes. So there are two high-level mechanisms to attach to logs. So if you say console log here, you have something called real-time logs, which as a developer you are interested in. This is a way basically to debug your function. So if you have that running here and you go and execute this function again, you will see that it showed up here in the real-time log. So this is a help for the developer to understand what is going in their code. If you are a SaaS company that buys Extend, a dedicated Extend instance, there is also a facility which allows them to plug in AWS Firehose endpoint to intercept all the logs generated by our platform. And at that point, today I think AWS Firehose allows you to store the logs in S3, Redshift, and Elasticsearch, I believe. And I think they will be adding more storage options down the road.
When you implement Extend on your website, what is the boundary between the function execution and the editor? How do you do it? Do you just invoke the editor with an event you are going to, with a certain structure you are going to send? How does it work?
So this is actually very simple. If you look at the settings page here, sample 0 CRM application, this IDE, the editor, is a React component that we provide that SaaS operator like 0 CRM can basically embed in their site. It can be white labeled, skinned, CSS can be modified. It's been designed to basically allow the SaaS operator to create a look and feel as if it was the integral part of their site. Now the editor simply calls management APIs on the Extend instance, which basically create the endpoint, set the secrets, set some metadata, and so on. Later on, when the 0 CRM system at runtime decides to generate some event which requires execution of one of those functions, for example, a new lead is created here, click create new lead. In the core of the system, normally when you are using webhooks, you would at that point invoke some URL that the person customizing the platform has provided. Integration with Extend actually looks exactly the same because Extend effectively creates webhooks for you. So the function is still just a URL to execute. So from the perspective of integrating something like Extend into SaaS, it kind of layers on top of existing webhook architecture rather than replacing it. So at runtime, using Extend looks exactly like using any other webhook mechanism.
Okay, so it's a platform that is integrating Extend that manages the association between its users, its context, and the URL that needs to be called on Extend. Right?
That's exactly right. Yes.
Any more questions? Thank you very much.
Thank you very much. Thank you for having me.